I'm Rohan, and this is my Lab 4 presentation video. So the purpose of this lab was to use our knowledge of kinetic and potential energies to create a simulation of an oscillation in GlowScript based on a tracker video that was provided for us. So these are the formulas that was used in the GlowScript code. Bf equals Vi plus Fnet over m times delta t, the velocity update formula. Rf equals Ri plus V delta t, the position update formula. K equals 1/2 mv squared, the kinetic energy formula. Ug equals mgh, the formula for force gravity. Us equals 1/2 ks squared, the spring force formula. 2 pi times the square root of m over k equals t, the formula to find period of oscillation, rearranged to find k, the spring constant. E equals k plus Ug plus Us, the energy principle. And mg equals k times L minus L naught, which is just force gravity set equal to force spring, rearranged to find L naught, the initial length of the spring. So this is the tracker video that we are provided. As you can see during this video, there are blue dots following the weight around. Those blue dots tell the time and the location of the weight in the video. From that data, this tracker code was, this GlowScript code was made. The blue ball with the blue line is the path generated from GlowScript, and the red ball is the actual path taken from the video. As you can see, they are not that far apart. So as far as code goes, this is the code that was used to set some initial variables. G equals 9.8, the force of gravity, Ks equals 6.81, found from this formula. L naught equals 0.125, found from this formula. These 3 lines of code were used to find the position of L. And these 4 lines of code were used to set the kinetic energies, force gravity, force spring, and E total. So these lines of code were used to update all of the values. Initial variables were set for all of the energies. This is just the gravity vector, negative mg. For spring, negative ks squared, ks times L hat. Fnet is just a combination of those two. Ball.vel found using the velocity update. Ball.pos found using the position update. These lines of code are the exact same as before because they can also be used to update the values. And these lines of code are also the same as exact before. K equals 1/2 mv squared. But there are deltas involved now, which is just the new values subtracted by the initial values. So these are the results from my experiment. As you can see here, the x graph, the x position versus time graph, is very similar with just a small offset between the prediction and the experimental. And in the y graph, despite the periods being the exact same, there's a discrepancy in the heights of the y position versus time graph. So what does this mean? So is the energy principle satisfied? Yes, it is, because as you can see here, U spring and U grav are almost identical, with whichever side having the kinetic energy being just slightly smaller than the other to equal 0, since the change in energy is 0. So the prediction here, why do we get different periods of oscillation? So when I use Y values, it's 1.519, and when I use X values, the period is 1.646. Well, as you saw in my GlowScript video, the path is not a circle, it's actually an oval. So this means that one period will be longer than the other.